Start with user-defined types, which we call it as a, I give examples with the UDT, user-defined types. Let's say, let me copy a stub with 37 UDT, which is called a user-defined type. Okay, right. So far we have been working and then using the defined types in the sense with the types that are already defined in Go. Uh, for example, I mean the numbers like all sorts of integers, floating points, and then string, boolean, and we also gone through arrays and slices, maps, etc. Now we are going to discuss about user-defined types. User-defined types are generally we call them as we can start with the structures. Structure is a user-defined type. Uh, Based on your requirement, generally based on your business needs, you model your uh, business entities. Generally, those are called user-defined types, structures. There are no classes in Go. Go is not an object-oriented programming language, so whatever you do uh, in object-oriented programming language, their things are little different in Go. Okay, so if you're working with Go, you need to understand the idiomatic approach of Go. We seldom talk about polymorphism. We seldom talk about there is no inheritance, in fact, but we use composition. There is no inheritance at all. There is only composition. We don't talk about inheritance in Go. There is no direct way of creating a constructor, but there is an idiomatic approach of creating kind of a constructor, but no direct constructor. There are certain things that Go way of doing things. Okay. Go doesn't have direct public private kind of an access modifiers or access specifiers. Rather, Go has got restricted or unrestricted fields with respect to the package. There are certain things in Go which are pretty native to Go. Not You don't find them in general, like in general object-oriented programming languages. Like, how do you create a user-defined type? Particularly, I'm talking about a structure. Type is a keyword you have to use. Name, for example, I would like to use something called person, which is of type structure. Person has got name, for example, email, maybe contact number. These three are three fields. Okay. Person is a type. Person has got name, email address, and contact number. Okay. If you can also give like this in a single line. Okay. Because all these three types belongs to the same underlining basic type, which is called string. So you can give. So person is a structure. So how do you create a variable for this particular type, which is a user defined type? How do you create a variable to the type? Generally, you can say var p1 is person. How can you access all the fields? P1 dot name, I can give as my name. P1 dot email, I can give, and then P1 dot contact number, I can give the contact number. Okay. Name, email address, and then contact number are three fields. You can access the fields of a structure by using this period operator. Okay. Similarly, you want to print down all the details. I want to print name. Okay, you can give p1 dot name. Same way, you can get the details. Email. Okay, this is how you can create a basic structure, and then you can access the fields like this. Okay, I can run this. You have it printed name, email, and contact numbers. You can also create a structure, a variable like this, where P2 is person equal to, you directly would like to give the values person of, because it's a structure, you can pass the values with the braces, name, maybe, okay, Jitendra, uh, and then the second field is email, for example, and then contact number. I can give a contact number, something like this. We can also create like this. Since fmt.println is a developer-friendly print, formatted developer-friendly print, you can directly print F2 or P2. It prints in a format that developer can understand. Generally, fmt.println you don't use in a production grade applications. In production code, fmt.println is kind of a uh, print, kind of a debug print actually. You don't write. If people use, but I don't prefer to use fmt.println in production application. You want to print something, use a logger and all. fmt.println basically is a very costly operation. I'll explain you why it is very costly operation later on. Well, I'll explain you during escape analysis why it is a very costly operation. Fine. You can also create with a shorthand declaration. Let's say p3 equal to colon equal to person of name, email, and contact, and then you can create like this. So you see that there are three ways you can create a variable of p1. You can give values or printing values individually. You can create a variable of p1 person, sorry, from the person structure. You can access assign values like this within the braces. I have printed it. And P3 is a shorthand declaration, directly colon equal to with a put a person and then assign values and then print P3. Generally, in Go, what happened is there are no constructors. There is no direct uh, way to create a constructor. In fact, constructors, no concept of constructors, but generally, in an idiomatic approach, that means how the industry, how the community has been following so far is they create a function generally with a name called new. It is kind of a constructor. Let's say name, email, and then contact number. You're going to get a person. This approach is used. That means return person of name is name, email is email, contact number is contact number. New. So what we do, for example, P4 equal to new of this you see very regularly in Go. Okay, new means maybe, New, there are multiple types, then new belongs to which type. So yeah, some folks write like this, new person. It depends on, because you're talking about person, so new person, because if there are more types, you can write only one new. There is no polymorphism concept in Go. Okay, I could see that. How do you write polymorphism in Go? Basically, you people use it, say that we can use it through interfaces, but generally Go doesn't support polymorphism, particularly the static dispatch kind of a thing. Okay. Compile time polymorphism is not, because Go's approach is, are you short of names? Why do you need to use the same name? Are you short of names? Is the approach, is the question that it arises, because I used to read the uh, emails, discussion in the groups, Golang groups. Then they initially, a long ago, immediately the answer, someone has asked why there is no polymorphism. The answer is, are you short of names? Why do you want to give the same name? Uh, that's got to be the answer. So this is how, fine. However, this is how you can create a basic structure in Go language. We'll go more advanced. This is first the beginning. Okay, this is how you can go and then print the details and then fine. Let's go to the another example. I name it as user defined types. Right. Let's say that I create a rectangle which has got length and then breadth. A rectangle which has got length and breadth. Okay, L and B. I also create area and then perimeter. I'll tell you why I have created this later on. Fine. As a practice, I give new rect. That means I got to give the length and breadth, which is of float 32. I'm going to get the rectangle. That means return rect of L is L and then B is B. These two values will be evaluated and put it there. Fine. So I have a rectangle and then I create a new rectangle, which is going to give me the rectangle, kind of a constructor. Again, there is no concept of constructors in Go, but this method, this kind of a method is used. You can give any name, but generally the community gives as new. The community give it as new. That's the reason we have given as, I gave it as new. Right. Now I want to find the area of rectangle. I want to find the area of rectangle. So I will create a function area of rectangle, which I'm going to get the area. Return, let's say r dot a. I want to store the area r dot l into r dot b, and then I return r dot a. Area is a function. Okay, area is a function. Remember that. Similarly, I want to write the perimeter. Perimeter is a perimeter of a rectangle. Perimeter function, area function of rectangle, perimeter of a rectangle. Perimeter, again I pass, so r dot p equal to, I give r 2 into r dot l plus r dot p. return r.p. So I have got area and then I also got perimeter. Both of them I got. Fine. Now I go to my main. I say R1, which is a shorthand declaration, new rect of, maybe I give 12.4, 13.6. So it returns an object called R1. Okay, let's say area A1 equal to area of R1 and then perimeter P1 equal to perimeter of R1. So area A1 of R1 is A1, perimeter P1 of R1 is P1. So you get area and then perimeter of rectangle. Fine. You want actually exactly the digits that uh, you want to calculate. Okay. You can use printf area of R1. It is percentage 12f. A1. You can also give like this. That 0.2f printf function can give you the more granular control. Perimeter of P1. You can give how many deserts you want to print. It gives you those many deserts. Let's say if I give 3, you can have more than 3 deserts. However, 3 or 4, whatever. Now I want to print. I want to see that how these values are printed. Two things here. Area is a function. Area is not a method. Remember that area is not a method. Area is a function. Before going to do that, I want to print actually what the values are stored in A and P. F1 dot print line. I just want to print A1 comma P1. Sorry, R dot A comma R1 dot A comma R1 dot P. So what would be the result? Is my question. You'll be what surprised. It's not surprise. You must know this. The result is 0 and 0. The reason is every time you pass anytime you pass area function, actually it is a call by value. That means a new rect variable is created within the function and then this R1 values are passed to here. So whatever you are changing here, they are attached to this particular object, which is different, which is not same as this one. Both of them are different because it's a pass by value. It's a pass by value. So this is the biggest problem. It's a big problem because you are not these values are not retained with the actual object. So what we do is instead of passing pass by or call by value, we do it pass or call by reference. This got to be the reference. Just because this is a reference, okay, you don't need to use any kind of star over here, like we have seen even in arrays, pointer arrays. No, you don't need to put star of uh, R and then you don't need to do this. You don't need to do. You can do also, there is no problem, but it's an additional syntax. You don't need to do this. it can understand that, okay, this is a pointer, so we are working with the address of this. Okay, you don't need to do this directly, just call with a r dot a. The moment you pass over here, then two things. You can pass the address over here. Let me create R1 as rect of L is 12.4, comma B is 13.64. Okay, you don't need to create separately a pointer. You know that you can just pass the this variable the address, because this the address is assigned to the pointer. Here you are passing to the pointer. The address is assigned to the pointer. Now, when I go and run, the actual values are retained in the because we are passing the same object. We are using the same object instead of it's called by reference, call by value. It is called by reference. Then generally, if you look at this new function always returns a pointer. This is how the new functions are created. The reason is new function is going to give you the a pointer. That means what I do R2 equal to new rect of 12.42 comma 13.64, and then you can have A2 comma P2 equal to area of R2 comma perimeter of R2. So you got to print fmt dot print line area of area of area A2 of R2 is A2, perimeter P2 of R2 is P2. You want to print like this, printing direct values of R2, R2 dot A and R2 dot B. Printing direct values of area and perim perimeter of R1, R2. Okay, this is how we generally do. Uh, so the pointer, the difference between a normal uh, uh, input parameter and pointer input parameter. Normal is passed by value and the pointer is passed or called by reference. Fine. And coming to that other thing, here area and perimeter are actually functions. Okay, area and perimeter are not methods. Area and perimeter are functions, they are not methods. Methods are called with a period operator, r1 dot area, r1 dot perimeter, but functions are called with a uh, directly like a normal variables. So how can you create a method in Go? Methods are attached to types. I repeat, methods are attached to types. I'm not saying methods are attached to structures. I'm saying types because there is a much more interesting concepts we will discuss later on. That's the reason methods are attached to types. It's fine. I can create a method area How can it be a method? The input parameter, whatever you pass here, it could become a receiver. Let's say, which is called a receiver. Again, the same concept. If the receiver is a normal receiver, then it's a pass. Just the parameter becomes a receiver. This is called as a receiver. How do you attach a method to a type? By creating a functions with the receiver, then they are called as methods in Go. It's not like you don't go inside and create in Go. You just attach them. How do you attach them? Just put a receiver. Again, the receiver, if it is a normal receiver, the same earlier issue comes. If it is a pointer receiver, then the uh, same thing is used elsewhere, everywhere. Similarly, I have something called perimeter. This one, I put it over here, and then I put it over here. So again, there are two kinds of receivers. One is a normal receiver and the other one is a pointer receiver. And the name, you can give any valid identifier, but generally the idiomatic approach in Go is a single letter. People give single letters, most probably two letters, like a variable name. Can't I give full name or like some small letters, rect and all? You can give. It's not going to stop you not giving. You can give. There is no problem at all. You can always give. But generally we don't give. We give a single letter. That is how the community does in Go. The Go community does like that. It doesn't give. It gives like that. Okay. So area and then perimeter like this. We create. These are the methods because there are receivers. So how can you use these methods? Let's say I create R3 equal to new rect of, maybe I give same values just to get the same results, and then A3 comma P3 equal to R3 dot area. You see the dot comma R3 dot perimeter. So the dot, you could see the dot. Dot is a method. Earlier we call it as a function. Now we are calling it as a method. The reason is we have created a method by attaching a receiver. So this is called as a receiver. Usually the question comes, when do you use pointer receivers? When do you use normal receivers? Generally you have to use pointer receivers. 99.9% you have to use the pointer receivers because every function call or method call, you cannot have a new object which consumes a lot of memory, and then the state is not maintained. You have to use the same object everywhere. So you always use the pointer receivers. Okay, you don't use normal receiver. Very rare scenarios you use. Maybe this is creating a new object. It is working. A function is working on a new object. Let's like draw a rectangle, draw a line or something like that. uh, we may use, but very rare cases, very rare cases. Okay, just seldom. I 99.99% I use pointer receiver because we are working with methods on a particular object, not a copy of the same object every time. Fine. So I'm going to print. I'm going to print A3 of R3, A3, P3 of R3 is P3. Here also I put R3, R3. I put it as R3. However, you know that you get the result. Fine. You can also create an object with a normal new function, built-in function. We already discussed about normal built-in function. New built-in function we can also create. new of which is going to create a pointer. R4 is a pointer. New of is going to create something R4. Similarly, you can do whatever uh, whatever you can give R4 dot uh, length equal to 12.4 and R4 dot breadth equal to 13.64, and then you do the same thing. Okay, you can do this. So this is how you can create a type. Okay, you can create a method. Okay, you can access values of the type, etc. You can create methods. These are methods. These two are methods. These two are created as functions. These two are created as methods. In a way, this is kind of a polymorphism because the name of the function is same, but two different ways. But still, Go doesn't talk much about polymorphism. Actually, we ask questions. How can I create a polymorphism? Because Go doesn't support polymorphism. The concept of polymorphism is not there in Go design. Polymorphism is a concept of object-oriented design. Okay, Go is not an object-oriented programming language. I always call it as Go is a hybrid. You can do most of the things you do with object orientation. You can do things that you do with the functional programming, you can do with Go. You can also do things that you do with the procedural programming generally you do in Go. So you can't call Go as a object oriented, Go as a functional, Go as a procedural because Go supports almost. So I always call it as Go as a hybrid uh, programming language. So this is how you create basically this is how you create structures, basic structure. We will see more. There are a lot of things that we have to discuss about this. We will see more and more, but just to begin with, this is how it is. Okay, okay, let me create another example. So interestingly, in Go language, you can also create a struct uh, without a uh, without field names. Let's say, for example, I have something called color code is the structure. For example, I have only two fields, which is called color code and color name. Let's say I can give color code as integer and color name as string. This is a structure. In fact, this is called anonymous fields or field or embedded field. Technically, you can create it like this in Go language. Color code is a kind of a type. Okay, color code is a anonymous field or a embedded field. What does it mean? What does it mean? Color code is an anonymous field or a embedded field. What does it mean? You can create this color code. Uh, let's say I create new color code. is a type. I have got a new color code is a type. For example, okay, code name. Code is integer and then name is string. Assume that it's a color name. Color code. Okay, color code. Then return. Let me put it as a color code and return color code of code. Sorry, int is code. It looks pretty uh, different. How can you create a int as which is a type of the field? How can you give it as the name of the field? You can technically you can do that. So C1 equal to new color code of I would like to give 101. For example, it is red. Okay, I want to print fmt dot print line. Sorry, uh, function CC, which is called color code of display, is going to display fmt dot print line color code is cc dot print. Okay, fmt dot print line color is cc dot string. So string and then integer or fields still you can use them like that. Let's say c1 dot display, it's going to display the uh, color code and then color. Okay, okay, it's a color code and then color name, right? You see that this is color code and then color name. This is how uh, you can do that. So integer and string. For example, I want another field. Generally, you cannot have another in string. For example, additional color name or additional color code, something like that. Okay, full name, full color name, or RGB that uh, fields. I can give float, but I cannot give another string or I cannot give another int. Here, the an alias fields comes into the picture. You know that I can create an alias field. For example, type uh, full color full color equal to string, for example, or uh, another string equal to string. So this is not a new type. Remember that this is not a new type. It is just an alias. We have already seen that this kind of things with rune and then byte and then any. This is just an alias. This is not a new type. It's just an alias. Okay, this is just an alias. So what I can do is I can put another string. You can give another string here. That means you can go and then give another string c1 dot another string equal to maybe something called full red. I'm just giving, there is no much meaning in c1 dot display full color is c1 dot another string. So what is this another string? Another string is a let me give it as a small letter. What is this another string? Another string is an alias. So since the name is different, even the type is string, there is name is different. You can add another name. Another string is not a new field. It is just an alias for string. Since the name is different, it can be used as a field, because you cannot have two strings over here, but you can do that. Okay, because it's the name is different. Okay, this is called generally the alias. Sorry, this is called the structure fields without names of the structure. Okay, you can create struct fields without names of the fields. Okay, there are no names. You can just create struct fields like this without names. This is what actually this is a constructor kind of. Okay, cool. I hope you understand what I'm trying to explain. So this is called a struct field without names. Okay, without names, just the field types are going to be used. There are no names to the fields. This is possible in Go language. Generally, when do you use it? If you have few fields, if you have few fields, uh, small, um, uh, your structure is only one with one or two fields or three fields and all. You can always use these kind of things. Okay, uh, that's it. So uh, that is how you can create, and then this is how you got to use it. This is a field with the alias. Fine. I hope you understand how to do this. Okay, next go to the another one, the 40th example. We create a type, we create a struct with UDT composition. Composition is there is no concept of inheritance in Go, but there is a concept of composition. Composition means one type object you are going to use in another type as a field, which we call it as a composition. And there are different design patterns, that promote composition a lot. Some design patterns that promote uh, inheritance a lot. But Go doesn't support inheritance. Go has got only the composition. There is another way that looks similar, little bit of similar to inheritance, but there is no concept of inheritance as such. Let's say I create a same person. Let's say I create employee, which is of a struct. Employee has got an ID. Employee has got email, and there is something called address. Employee has got the line number one, city, state, country, pin code. These are all give it as string, and contact. These are all strings. Now I would like to add address as well. So this is the address type I would like to use here. Address as address. In Go, the name of the field can be the name of the type, name of the user defined type. That means address in many programming languages, which is not allowed because address is already, for example, a type. So you cannot give the field name as the address, but in Go you can do that. Okay. Okay. You can give in Go like that. Even though it is telling field name is unused or something. I'm just telling you. You can do that like that in Go. The name of the field can be the name of the type. Name of the field can be the name of the type. Let's say I create something called address, a address. I can also give it as a pointer over here. Address display, which is going to print line 1, a dot line 1, city, pin code. Similarly, I can also print the display the employee, which is going to display the employee. You want to call the function something called display of the address because address is passed here. You can also see e dot address dot display. You're going to call the function which is of address. Okay, I can say fmt dot println address. You can print the address. You can directly call the address over here. So now how can I create the object employee object? So I can create two new functions. Number one, I can create two new functions. Uh, let's say function new address first I create, which is going to return the address. So what does address contain? Line 1 city, state, country, pin code. Line 1 city, state, country, pin code. I'm going to get it as address of line 1 is line 1, city as city, state as state, country as country, pin code as pin code. I'm going to return this, which is called new address. And then I create, let me put this one somewhere over here. I create new employee, function new employee, employee ID, name, email, contact, address, which is going to get the employee. So new, sorry, return employee of ID is ID, name is name, email is email, contact is contact, and address is address. So if you have a look at it, this is employee object, employee type, which has got ID, name, email, contact, and the other one has got address. Address is a another type. I'm passing employee with the address over here. I'm going to get all the details of the employee and address. So how can I create? First, I can create address as new address, new address of maybe line 1 is okay, uh, electronic street, city maybe Dubai, state is Dubai, country is UAE, and then pin code, there is no pin code over there, but okay, 001 for example. A1 is the address. I want to create employee E1 equal to new employee of ID 101, name, for example, address, email, and then contact, and then the address which is called A1. So you can call E1 dot display, which is gonna display directly all the details of the. So you get the details of the employee and then you get the details of the address. For example, I say that okay, I don't have to use new, but I want to directly create, let's say E2 equal to employee of, like this you can use ID equal to 102, name maybe Jitin, email equal to jitin at gmail.com, and contact equal to, you can give some contact number, and then the next one is called the address, so you have to put address, but address is a pointer, so specially you have to write it as a pointer, address of line 1, maybe electronic street, city, Dubai, country, UAE, and a pin code. There's no pin code for UAEs, there's, but still I just gave like this, maybe just 97. I just gave. Okay. You can also create like this without kind of a new function. We don't call it as a constructor, we call it as a new function. Similar to constructor, but it's a function, normal function. So you can directly create like this. So still you can use e2 dot display. E2 dot display. You got to get the details of the uh, sorry, second one. Okay. So this is what actually how you can create a structure, embed a structure. There are so many things we're gonna discuss. This is just a beginning with respect to user-defined types. We will have, I think, another 2 sessions or even more than 2 sessions we'll be spending on user-defined types. We'll go very depth of user-defined types. Uh, this is just for 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 today. Any questions?